Hello and welcome. You are looking at the Algebra 1-2 Chapter 2 review containing the closure assignment problems from Chapter 2. Let's go straight on through. Number 101. Here we go. For the line graphed at the right, let's find the slope, find the y-intercept, and write the equation. Now the equation meaning in slope-intercept form, meaning if we find the slope and y-intercept, we would be good to go. So let's go and find those two values, then we'll be able to write it. All right, find the slope. That is using the letter M. We'll be seeing that in future problems, I think in the next problem actually. To find the slope of a line, doesn't matter where you're at. What matters is what the rate of change is of that line. So if I pick like a point right here, and another point that the line definitely crosses through, like this one right here, what I want to find out is how much did this thing rise as it was running. Now, run is referring to the x direction to the right. That is positive run. So technically, as this guy is running, it's not rising, but it's falling. But when you're falling, you are rising in the negative direction. So what I'm trying to see here is how much did I run from here to here? Well, I ran 2 units over. How much did I rise? I rose -1, or I fell 1. So that's a negative number there. So that's your change in y right here. This is your change in x. So rise over run is -1 over 2, which is -1/2. That's the exact same thing, but I'm writing the negative in the middle instead of regarding -1, or -0.5 because that's an exact decimal. I'm going to use this one though as my answer. Now it didn't matter what 2 points I chose because this is a straight line, meaning the rate is always the same regardless. What if I picked this point over here and this point way down here? Okay, well the idea is the rate is the same. This is, I think we're going to see some word problems later, but these slopes being negative might have you think up a word problem that says something about how you're losing something. You're losing money, you're losing weight, you're losing distance, whatever it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe it's a problem that says after 10 seconds, 2, 3, 4, 5. You have, you have erased 5 words. I don't know. But the idea is this keeps the same rate as this guy right here. These are called slope triangles. If you can see this big triangle right here where you make a right angle and you determine how far you travel in the x direction, how far you travel in the y direction. Well, -5 being your rise over 10, if you reduce that, that still reduces to -1/2. So you can see why these two are the exact same thing right here. So it doesn't matter what 2 points you pick, the rate is still the same. So it's always going to be -1/2. You want to work toward reducing that fraction if you can. So that's my m. Your y-intercept, which actually uses the letter b in the equation in slope-intercept form, is the place where your graph crosses, or where your line crosses the y-axis right here. So that point of intersection is right there. Y-intercept not only means that, but it is also the value of y when x equals 0. If you think about it, here's the x-axis. This point here is, let's say 1, 2, 3, 4. This point is 6. This is x equals 5. This is x equals 4. X equals 3, x equals 2, x equals 1, x equals 0, x equals -1, -2, etc. When x equals 0, what is y? Well, that point is 0, 1. So the b is that y-intercept. That's the y value there. So b is 1. So your equation, write the equation. Well, the form is y equals mx plus b. We're going to look more at the equation in its entirety, but what we're going to do is substitute the letters, or for m, this value, and for b, this value. Y and x will remain untouched because that is based on what points we choose, what x, y values. So the equation will be y equals -1/2 x plus 1. So the basis of this equation really is that you're going to start at 1 in a way, and then you are going to go down 1 and you're going to run 2 each time. Down 1, run 2, down 1, run 2. And you'll stay on that line. So there you go. Okay, number 102. Find m and b in the following equations. What do m and b represent? Okay, so we just looked at y equals mx plus b. You say that enough, you'll remember it. It's not even a matter of memorization. It's just, it'll be conditioned and lodged in your brain to know. So just kind of find the place here. This is m for this one. So m equals 2. I'm going to write 2 over 1. You're going to see things more as fractions, especially when it comes to graphing them, like we're going to next. Your b value is a positive 1. What do they represent? M is slope, once again. B is y-intercept. Slope of the line, y-intercept of the line. Okay, so there's that one. Next one, y equals 2/5 x minus 4. Your m value is 2 over 5. Okay, and then your y-intercept, your b value, is negative 4. So we're going to graph both. Okay, we'll make a little bit more sense of what it is we're looking at. So let's first do A. I'll do it in red because that's the color I was using there. First, what I'm going to do is I'm going to start at the point 0, 1. The reason is because we need to know, like, we need a reference point to begin at. This is the one that I know for sure it goes through. It goes through the y-axis at y equals 1 when x equals 0. Okay, now I start to apply my rate. And like I said, 2 is the same thing as 2 over 1. Remember that your slope is your rise over your run. So I will still be running 1 each time I rise 2. So here if I rise 2, 1, 2, I can run 1, and boom, there's another point that's on this line. I can do another rise 2, run 1, that's another point on this line. And I can continue that pattern for as long as I feel like I need to make sure I get a very straight line through here. Now it also goes in the negative direction, and this is where things kind of get iffy if you're not too familiar with fractions here, or the slope idea. Going down 2 is going negative 2. Okay, I fell 2. Now I'm going to run to the left 1. That run is negative. So a slope of negative 2 over negative 1 is the same thing as positive 2 over positive 1. So although we went in the negative direction, we went in the negative direction both ways. That fraction is still positive. So this is still a positive slope, even though I'm looking at it this way. A negative slope goes downward as x runs to the right, not as x runs to the left. So just be very cautious of the fact. And let's go and graph this. Okay, the other thing that these lines need are arrows at both ends. It indicates that this is going on forever. There is no restriction in the domain or the range here. This will keep going. So there's your graph there. Let's get this stuff out of the way. Okay, that is for A. For B, let's go ahead and plot this. Now, we're going to start at negative 4. So we're going to start way down here. 1, 2, 3, 4, when x equals 0. Now the slope is 2 over 5. Don't be too alarmed by having a fraction saying that's hard to graph. This does not mean go up 2/5 and go over 1. Well, it does mean that, but I wouldn't suggest you do that. It's the same thing as going up 2 and going over 5. I would plot that point right there. Kind of already running out of room. Go up 2, go over 5. Okay, and same thing here. If I go down 2 and go to the left 5, I will still have a positive slope, and I will still be going on my desired path. That line right there. So let's go ahead and draw that line there. All right, make sure you have arrows on both ends, and there are your two lines. Okay. Now we're going to be looking at some word problems in a second. We're going to be talking about things where things start at and what their rates are, and we can ask, when does one thing pass another, or what, or like whatever else. You can see this is a sharper rate and it starts higher up. If we're talking about this as starting value, this has a lesser rate and starts at a lower value. So you can see this will continue to climb farther and farther away from this line right here. Okay, number 104. Here's an example of a word problem with that same idea. Shirley starts with $85 in the bank and saves $15 every 2 months. Write an equation for the balance of Shirley's bank account. Well, surely I will do that. But before I do that, I want you to start thinking about what this is as an XY table, a very curvy XY table because I can't seem to draw straight. Let's consider her first month when she opened her bank account, month 0. It's her starting month that we're referring to. In her starting month, she had $85. Okay. 2 months later, 2 months later, she saved another $15 more. So when you add 15 2 months later, you'll see that Shirley still now has $100 in there. Another 2 months later, in month number 4, she saves another $15. So she has $115, etc. So I want you to get very familiar with how lines work. There's a constant rate that's being applied. And in her case, every 2 months, she adds another $15. So this could keep going. The two important things here will be this rate, 15, rising 15 every 2 months, and the starting value, what she began at. Because if we're talking about y equals mx plus b, if we're going to use that form right here, I want x to represent the number of months passed. And y is going to represent the amount of money, amount of dollars saved. Okay, so I'm not going to graph this, but on a graph, you would be starting at the point 0, 85, meaning your y-intercept is 85. And every 2 months, you gain another $15. So the slope is referring to the rise over the run. Your slope m here is going to be rising $15 every, or saving really, running every 2 months. That is the slope. So what we can do is we can even check with this table and make sure it makes sense. Your y-intercept b, your starting value, is 85. So your equation is y equals 15 halves times x plus 85. I could have used 7.5. That's the same thing here, 15 over 2. So I could write it like this, 7.5x plus 85, whichever one you prefer, plus 85, as long as your decimal is an exact one, then it's okay. So let's check and see if this equation thing kind of pans out here, if this makes sense. You start at $85. So every 2 months she saves $15. How much do you imagine she saves every 1 month? Well, half of 15, 7.5. So when x equals 1, you're going to add $7.50. 7.5 times 1. You're going to add that much to your 85. When x equals 2, you're going to be adding 750 twice. 750 plus 750, that's $15. That adds to 85. You get 100, etc. When x equals 4, that is 4 times you're going to add $7.50, which is $30. 30 plus 85 is 115. So you can see how this equation works here, and it's based on what x value you choose to get your y value, or the other way around. Number 105, find the slope for each linear relation described in the tables below. So that's why it was important. I was talking about this last one right here. We wanted to see how much we rose in y values in comparison to how much we ran in our x values. We're going to do the same thing here with these sets of problems. Here we have some different points, and you have to remember these are points just like the ones that we saw in the very beginning. Like this is a point, -2, 19, -1, 14, 0, 9, 1, 4, and 2, -1. A couple things of note here. You can see that x is running in the positive direction this way. As this is happening, y is decreasing. So make sure that you recognize your answer should end up being a -1 when you're imagining what your slope will be. Like when you end up calculating it, make sure that you get a negative answer. All right, let's take a look at what x is doing here. Every time it looks like it's jumping 1, you're adding another 1 to it. They don't have to put it in this order, and they don't have to put things consecutively. Just like on the last problem, they were jumping 2. That could be happening here. So you have to be careful about what that jump is. Don't just look at the growth or shrink rate of the y value. But as we do look at this, it seems like every time we run 1, we are falling 5. This is kind of like what we were talking about before. If it's losing weight or whatever it is, like every month you go on, you're losing another 5 pounds. All right, that's fantastic. But we want to find out what that slope is. It's rise over run. So it's the change in your y values over the change in your x values. This is -5 over 1. Or you could also simply put -5. But the fraction -5 over 1 is probably more useful for your graph, and this probably looks cleaner in an equation. They're not asking us to find the equation of this line, but if I did, I would be looking at that slope and this y-intercept right here. It's the value of y when x equals 0. That equation would be y equals -5x plus 9. So every time you increase one other x value, you are decreasing another 5 here. Okay, letter B here. It looks like x is jumping by 1s again. Cool. So every time I'm increasing 1. Okay, I could be doing that again. Now, every time here it looks like I'm adding 9. I'm going to try a different approach this time. Remember when I said it doesn't matter what 2 points you choose when I was talking about that graph way over here? Okay, didn't matter how far I went. Same thing over here in the table. Doesn't matter what 2 points I choose. In fact, they don't need to give us this many points. They only need to give me 2 sets of points. I could go from 2 to 6 if I wanted to. And I want to. I'm going to add 4. From 22 to 58, I'm going to add 36. Let's see if this checks out to give me the number 9, just like this would have. 9 over 1 would have been my slope here. Let's see this slope here. M equals rise 36 over run 4. 36 over 4 is 9 over 1, or possibly more simply, 9. Okay. That's all we needed to find out, but I want to help you a little bit more. What if they ask you, excuse me, that's a text message. What if they ask you to find the equation of the line, meaning we still need the starting value? Well, unfortunately for this table, it doesn't look like we have a value when x equals 0. But could we find one? Absolutely. Let's go ahead and go back a couple. If I subtract 1 in the x direction, because I added 1 this way, when I add 9 this way, I should be subtracting 9 this way. That's at the value 1. When x equals 1, y equals 13. Let's do this one more time to get to 0. I know I'm making a mess of stuff here. But when x equals 0, let's subtract another 9 from 13. Y is going to equal 4. So you can still get a starting value. You don't have to use a table. There are other ways. We might run into them here. But this one will have an equation, y equals 9x plus 4. You start at 4. Okay, starting value is not just where the table starts. It is when x equals 0, your y-intercept, and then every time you add 1, you add 9 this way. Okay. Number 106, write a rule for the given tile pattern. How many tiles will be in figure 58? This one's always interesting. I like how people are able to always connect what happens when you jump each figure number. This is a table example again. But we're also going to be looking at a good rule here. So what happens from figure 1 to figure 2 is it looks like you increase 2 tiles this way and you increase 1 tile this way. And this pattern continues from figure 2 to figure 3. You increase 1 tile here and 2 tiles here. So let's find out how many tiles are in figure 1. 1, 2, 3, 4, 5, 6. I know 2 has 3 more than 1, so that has 9. Figure 3 is 3 more than 2, so it has 12. So I'm going to start writing, so it looks like we're jumping 3 each time. But let's start coming up with a table. Maybe it's a little more helpful to write as a table with x and y. When x is, geez, I cannot do a straight line. Let's do that again. Very simply. There we go. All right. I'm going to keep one value open here for figure 0, but in figure number 1, x is referring to the figure number. We increase 3 tiles. We have 6 tiles. In figure number 2, we increase 3 tiles from figure number 1, so we have 9 tiles. In figure number 3, we increase another 3 tiles. That's 12. You can imagine figure number 4 would continue the pattern of adding another tile here and 2 more tiles here, which would look like that. which has 15 tiles. So this continues its trend. Figure 5 would have 18, 6 would have 21, etc. I could also figure out how much are in figure 0. Figure 0 is going to be pretty important here because it gets to say how much it had. Essentially what would happen is if 2 were added from figure 1 to figure 2 like this, figure 0 would have 2 removed from down here. So figure 0 would also have 1 removed up here, and it would just look like this. This would be figure 0, just a block of 3 like that. This one's important because this represents that starting value. It helps you write an equation, and furthermore, it allows you to make predictions about what farther figures would be. I'll show you why in a second. So again, x represents the figure number, y represents the number of tiles per figure number in each figure number. So your equation y equals mx plus b, you look at that growth rate. Every one you run, you add or rise 3, and every time and you start at 3. And every time that we add another x value, another figure number, we are adding another multiple of 3 to 3. So let's take a look at that. If I wanted to ask you how many tiles would be in figure number 10, okay, it wouldn't be a stretch for you to add 3 from this number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, right? 21 plus 3 is 24, 24 plus 3 is 27, 27 plus 3 is 30, 30 plus 3 is 33. That would give you figures 7, 8, 9, and 10. However, think about what we said we were doing. We were starting from 3, and we were adding 3 10 times. Okay? That is the same as multiplication. Multiplication is just a certain number of times that you add something. So I could just use this equation and use 3 times 10 because that's my figure number, and I'll add that number to 3. So starting with 3, we're going to add 30 more. That would give you 33. Okay? That's a short-sighted example. Let's look at figure 58. In figure 58, you're basically adding 3 to this number, 3. You're going to add it 58 times. So instead of literally adding it 58 times, let's multiply 3 by 58. Okay? So in figure 58 would be y equals 3 times 58. Whatever that number is, we are adding to 3. That will tell me how many tiles are in that one. 3 times 58 is what, 174? So y equals 177. In figure 58, I'll write it over here, there are 177 tiles. Now that image would look like, it would be like, and it would go long like that because, as you notice, we keep adding tiles this way and this way, so it would just get longer. And this one adds 2 each time, this one adds 1 each time. So it would be just this nice long looking thing. Moving on, solve for W. 6W minus 5 plus 8W minus 2W minus 3 equals 9W minus 24. Okay, when solving for a variable, first of all, your objective, the end result is finding a value that when you substitute it into this equation, the left side equals the right side. We'll make sure that that ends up being the case. So in order to do that, what I'm going to do is I'm going to divide this equation in half literally. I'm going to be separating the left side from the right side in such a way that I'm ignoring the right side. I can't draw a straight line. I'm ignoring the right side when I'm referring to the left side. So what does that mean? Well, let's just take a look at the left side as soon as I divide this actually. Let's take a look at the left side only. An equation has expressions on both sides. Boom and boom. An expression, like this thing right here, has no such equation tied to it. What I want to do, first off, is I want to simplify each expression. There's an expression on the left side, and there's an expression on the right side. To simplify it, it means if there are parentheses in the way, get them out of the way. If there are like terms to combine, do it. do some things to make sure you get this cleaned up a little bit. Okay, so what I'm going to do is I'm going to look at combining like terms. There are no parentheses, so I'll just combine like terms. A method that's always useful, if you'd prefer to do it, is find the terms that are alike and give them the same, assign them the same kind of thing. Like I'm going to give circles to every term that ends in W. Now keep in mind, I'm applying the sign in front of the term because that is the one that attaches to the value of the term. So these three guys right here, let's write next to each other. 6W plus 8W. Notice I didn't write minus 8W. That minus applies to the 5. And then minus 2W. You may rewrite things in order as long as you keep those signs with each other. And maybe you underline the constants. -5, -3. So here, I'm going to write minus 5 minus 3. Okay? Now I can combine like terms. These three can fuse together. When they end in W, just add the numbers in front of them. So 6W plus 8W is 14W. 14W minus 2W is 12W. Now, I'm not solving for W right here. I'm just simplifying what's here. -5 minus 3 is not -2, it's -8. Okay, that's the left side. The right side actually is already simplified. I can't combine these terms. There's really nothing I can do with this side. I'm actually taken care of there. So this side is already simplified. This is 9W minus 24. Okay, I've accomplished my first step. I have simplified each expression on both sides of the equation. Now I'm actually going to be looking at this equal sign a little bit more closely. There is a number that when I multiply it by 12 and subtract 8 is equivalent to a number that when I multiply it by 9 and subtract 24, meaning they're both the same thing. Let's see what number that is. Now, it's not through guess and check, meaning I'm not just going to try random numbers. The idea behind it is if we manipulate this equation in such a way that we can get 1W by itself on one side of the equation, then we will know what the result is. So how do we do that? We have to start isolating the variable W. Isolate W. In order to do that, I have to take any W's that are on this side and move it over here, or take any W's that are on this side and move them over here. To start with, I'm going to go this way, so that way my answer will say W equals, and also I know that when I move this over, by moving, meaning I subtract 9W, and I have to do it on the other side as well to keep balance, I know my number is going to be positive. So this is 3W. There's still a minus 8 on this side, and this equals negative 24. Okay, the W is still not isolated because it's being multiplied by a 3, and it's also, that whole term's being subtracted by 8. So let's get the 8 out of the way, the negative 8, I'm sorry. So let's reverse that operator. You have to add 8 to both sides in order to eliminate the 8, because 8 minus 8 is 0, or negative 8 plus 8 is 0. So this is 3W being equal to negative 24 plus 8 is negative 16. Okay. Now, 3 times a number equals negative 16. We have to figure out what that number is. In order to do that, don't guess and check again, divide by 3. If I divide this side by 3, 3 divided by 3 is 1. All that will be left on this side is W. Negative 16 divided by 3, not a very pretty number. In fact, I'm going to leave my answer as that. Anything else that I write is kind of a decimal approximation. This is a correct answer. There is nothing wrong with this answer. You are allowed to have fraction answers. W equals negative 16 over 3. You could plug in negative 16 thirds into your equation. I wouldn't recommend kind of going about it that way. It doesn't really work like that. But if I go ahead and substitute it in the original equation, if I go ahead and substitute it in here, 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 and here, I will get something where the left and right side are equal to each other, which is kind of sweet. All right, but that's your answer for W. Okay, number 108, copy and complete the table below for the rule y equals x squared minus 6x plus 5, then graph the rule on graph paper. Here's my graph paper, then we'll answer these questions. Okay, I'm going to do a lot of mental math, so feel free to write stuff down as you need to. If you need more help, on this stuff, I recommend you watch the Chapter 1 closure assignment. There is one problem where I go way in depth on it. If you fast forward or rewind enough, you will find that problem because it's a big table all taking up right here. And it's not a quadratic equation. It's a square root function, but it still does refer to how you can make your tables and make things work. Okay, but again, I'm going to do this mentally here. When x is -1, -1 quantity squared is 1. -6 times -1 is 6. 1 plus 6 is 7. 7 plus 5 is 12. When x equals -1, y equals 12. When x equals 0, 0 squared is 0. -6 times 0 is 0. 0 plus 0 is 0. 0 plus 5 is 5. So this point is 5. 0, 5. When x equals 1, 1 squared is 1. -6 times 1 is -6. 1 minus 6 is -5. -5 plus 5 is 0. When x equals 2, 2 squared is 4. -6 times 2 is -12. 4 minus 12 is -8. -8 plus 5 is -3. When x equals 3, 3 squared is 9. -6 times 3 is -18. 9 minus 18 is -9. -9 plus 5 is -4. When x equals 4, 4 squared is 16. -6 times 4 is -24. 16 minus 24 is -8. -8 plus 5 is -3. When x equals 5, 5 squared is 25. -6 times 5 is -30. 25 minus 30 is -5. -5 plus 5 is 0. Okay, before I move on, I want you to start taking a look. Maybe you start recognizing a pattern saying, hey, I wrote these numbers already. This point's kind of in the middle. And notice, -3, -3, 0, 0. If there's something else you need to understand about quadratic equations, it's that they have symmetry. They're not always symmetric right at the y-axis. They can be shifted over to the left or right. In this case, this one is shifted. So let's go ahead and apply that symmetry to this. It looks like this point is the vertex, meaning this is the lowest most point. Because x squared is positive, it'll go upward. This is the lowest point that it will hit, and then it'll start going up on either direction, the same height each time. If at 0, this height is 5, you better bet that over here at 6, this height is also 5, because you can see there's the symmetry that's being applied. And right here, this one will also be 12. I'm sure that through my explanation, that took longer than me plugging these next two ones in. You can try them for yourself. Don't take my word for it. But if you are doing this on a test or whatever, save yourself some time. Once you recognize you did the math right, once you recognize that you're having symmetry somewhere, that's the vertex. Everything else is going up from there. So what this table means is these are points to be plotted on this graph. So let's go and do that. I'm going to start at -1, 12. And actually, this goes up here, 10, 11, 12. It kind of runs off the graph. That's okay. Here's 0, 5. Okay. 1, 0. 2, -3. 3, -4. 4, -3. And actually, at this point, again, I don't think that I have to be looking at these points exactly. What I could be doing is talking about symmetry. Everything is symmetrical, and across this axis here is reflective, meaning at points that are the same distance away from this axis of symmetry, I'm getting points that are the same height. Notice these are the same height 1 unit away. 2 units away, these will be the same height right here. I don't even have to look at the table anymore. I'm just going, this is 3 away, so at this height, there's also a point that's 3 away. And up here, there's a height that's 4 away. 1, 2, 3, 4. Duplicate that over there. 2, 3, 4. It's about right there. So the parabola is this curve, and this will not be a pretty curve. Not very good at drawing right here on my computer. But it's a U-shaped curve that hits all these points. Oh boy, oh boy, oh boy. That goes up forever, but in both directions. And its lowest point that it hits is -4 in the y direction. We'll be talking about that in just a moment. Now this line here is not necessary to draw, but it is important to know that that is called the axis of symmetry, where it says the left and right side have equal points, or have the same distance away, equal distance, from the same height. So there's a terrible graph. Completely describe this graph. I'll go ahead and type that down here. Let's see how we want to describe this. We'll say it is a U-shaped graph with a vertex at 3, -4. It faces upward. It has x-intercepts, meaning the values of x when y equals 0. So starting to type interception. X-intercepts of 1, 0. So notice where it's crossing right here, 1, 0, and at 5 zeros, the values of x when y equals 0. 1, 0, 5, 0, and 5, 0. It has a y-intercept of 0, 5. That's the value of y when x equals 0. That one's right here and also right here on the table. Okay. I'll talk about the function and domain and range stuff next on here as a part of my explanation. The relation is a function. Why? Because for every x value there is only one y value. That's important. That's what's necessary for this to be a function. Remember, it needs to pass that vertical line test, meaning you can't plug in a value for x and get two different values out for y. However, you can have the same y value for different x values. Okay, so it's not about a horizontal line test, it's about a vertical line test. Now this will go up forever, it will never go vertical, but it is symmetrical. Okay, and it is a function. State the domain and range. The domain is referring to the values of x, meaning what values of x can you insert into this equation and get a value of y out? The answer is there is no limit on which ones you can choose. You can choose any and all real numbers. The only time you're really going to see restrictions on your domain is if you're maybe dividing by 0 or taking the square root of a negative number, at least when it comes to Algebra 1-2 material. There's another thing called logarithms that you are not going to do in Algebra 1-2 that would also give you domain restrictions. Now the range is a little different. It asks what values of y are accepted here. Is there ever a limit up or down that you can go? Up, no, there's no limit. This will go up forever, no matter what you plug in for x, negative or positive, or 0. However, it does only go down to a certain extent. It just goes down to right here. It stops at -4 and it goes back up again. So the lowest point it becomes is -4. So y is greater than or equal to, I think I actually have that text option here. Let's find it. There you are. Y is any value that is greater than or equal to -4. And that ends up being the range. You could describe it in words the way I did. This is a nice shorthand way of saying the exact same thing. So basically, here are the values of y that you will find on this graph. Okay, find the slope of the line that passes through the points -5, 7 and 10, 1. So let's go ahead and look at it with a graph first. And it's not expected for you to do a graph for this problem, but I'm going to use the graph to help explain how you can do it without a graph, if that makes sense. 10, 1 is all the way over here, which is unfortunate. See, the thing about these problems is sometimes the graph would be too big, meaning it wouldn't even fit on what you're talking about anyway. So that ends up being a problem when it comes to using the graph. So you can't expect to always use a graph here. The other problem is sometimes your values just aren't good whole numbers, so it's just not good to work with anyway. There are ways to do this without this graph. Let's go ahead and make this line solid. Okay, so the idea with this problem here is we need to find out what that rise and run, etc. is. So last time we did this, we counted. Now I'm going to count again, but this time I want you to notice what it is I do mathematically to get these counting values. So let's figure out how much it fell, 1, 2, 3, 4, 5, 6, negative 6, and how much it ran, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, negative 6 and 15. So we know that our answer is already going to be negative 6 over 15, or better yet, if you divide by negative 3, that'll be negative 2 over 5. Now, how are we getting this negative 6 and 15 using just these values here? So let's take a look. Negative 5, 7, and 10, 1. Okay, these are both different x, y pairs. Here's an x value, here's a y value. Here's an x value, here's a y value. Now, this does not mean x squared and y squared. This is just a second x and y value here. When we are finding the change in y, meaning how much it fell, we are taking the difference of this number and this number here, sort of. Or saying, how much did I have to go from 7 to 1? And I think those numbers are small enough that you can say in your head, oh, that's 6. We traveled 6. And I'll say, how do you know? Well, you do 7 minus 1. Right? Now, in this case, if I'm asking how much did you go from 7 to 1, you went backwards 6. So essentially, you went 1 minus 7. That's negative 6. You could do it the other way, but there's kind of something to that I have to make sure you do understand when you have that. Now the x ones as well, how much did we go from negative 5 to 10? Some people accidentally say 5. Be very careful. You go when you go 5 to the right, you reach 0, right? 1, 2, 3, 4, 5. You have to go an additional 10 to get there. So 5 plus 10 is 15. So that's 10 minus negative 5. Okay? Again, you are subtracting your two numbers to get there. 10 minus negative 5 is 10 plus 5. That gives you 15. So that's how we're getting those numbers here, negative 6 over 15, because this was slope as rise over run. So we had to figure out how much we changed in y and how much we changed in x. To do that, we did this guy here. Found the difference of our y values and the difference of our x values. There's actually an equation that looks like this. Okay, not something to necessarily memorize, just something to understand here. You're subtracting one y value from the other, 1 minus 7. You're subtracting one x value from the other. Now notice I subtracted negative 5. This number is negative 5. When you subtract a negative, it is adding. So that gives you a positive there. Now, what if you went the other way? Meaning, what if I was looking more at this point here, and I want to say, how much did I rise in this direction? How much did I run in this direction right here? What's going to happen here if you look at it that way? This will be you rose 6 and you ran negative 15, because running to the left is running negative. Slope is still 6 over negative 15, which is still negative 6 over 15. That still reduces to negative 2 over 5. This one I had to reduce as well, actually. And so we're good to go. Same thing with the calculations here. If I think of it this way, it's saying how much did I go from 1 to 7. This would be an example of doing 7 minus 1. 7 minus 1, which will give you 6, over your run. How much did I go from 10 to negative 5? This time we went backwards 15. So you do negative 5 minus 10, and that gives you negative 15. So you can see you're still going to get the same answer no matter what you do, because the sign is still going to be relevant there. Okay, so the only to me, the only thing that the graph will really help you with, unless you can visualize it right here, the only thing the graph can really help you with is where you don't screw up the sign. So pay close attention to the fact that when I did 1 minus 7, I also had to do 10 minus negative 5. But when I did 7 minus 1, I also had to do negative 5 minus 10. The order in which the values are subtracted means everything. It doesn't matter which one you do first. I could do x1 minus x2 and y1 minus y2, as long as I do x1 minus x2 and then y1 minus y2. I wouldn't do x1 minus x2 and y2 minus y1. That will change the sign of my answer. That'll make my graph go this way. And that's not what we're looking at. We are looking at a negative slope. So keep that sign in mind. So again, one thing the graph does to help you is it makes sure that you got the right sign in place. So maybe you accidentally did subtract it wrong and you got positive 6 over 15 or positive 2 over 5. Check your graph and say, oh, whoops, I subtracted a point a pair of x values differently than I subtracted my pair of y values. I'll just switch the sign and make it negative. So again, the graph can still help, but don't be expected that these numbers will always be nice, small, and tiny, and countable, and everything like that. Understand what distance means. It's the difference between your points. But we had to differentiate y values from x values in order to make it happen. And there's your general slope. Now again, the way that slope works is it'll still be on your line if you're doing it right. If I'm going down 2, I'm going over 5. Boom, there's a point. Down 2, over 5. Down 2, over 5. Notice I'm still on the line even when I shrink my slope. Left 5, rise 2. Right, still on that line right there. Okay, the last ones here, evaluate the expressions below for the given values. So I'm not going to stress too much on these except for referring to order of operations. The rest you should probably be able to do. So let's look at A first. This will be when x is -2. What I'm going to do every single time I do substitution is I'm going to wrap my values around parentheses. My x values, that is. Okay, let's figure out what this is. Now, order of operations says you must apply the exponent before you do multiplication. So I will not do -3 times -2 first. That would give me a different number. I'm going to do -2 quantity squared first. When I square the number -2, that's -2 times -2. That gives you 4. So this becomes -3 times 4 plus 4 times -2. That's -8. So that's -8, then plus 5. -3 times 4 is -12. We have -8 plus 5. -12 minus 8 is -20. -20 plus 5, not -25. It is -15. And that is the value when x equals -2. Okay, part B. Let's take a look at that one. When x equals 1, 6 minus 5 times 1, parentheses, minus 9, quantity squared. All right. We have 6 minus, let's work inside the parentheses first, then I'll square it. 5 times 1 is 5. Okay, 5 minus 9 is -4. All right, here I have 6 minus -4 quantity squared. Well, order of operations, let's do the exponent first before we subtract. I'm not going to change these signs yet and square it. This only applies to this. -4 squared is -4 times -4. That's positive 16. Now, I'm going to do 6 minus positive 16. 6 minus 16. That gives me -10. Be very careful with your order of operations. Don't just assume signs change for no reason out here. I was only applying this number here to make it 16. And I still subtracted it. Moving on to C. Here we go. Parte C. -4 over k, which is -8, plus 7. That becomes -4 over, so -8 plus 7 is -1. -4 divided by -1 is positive 4. Very nice, pretty clean. Not much. You can, I guess, if you do -8 plus 7 is -15, that'll mess you up, but not many opportunities to mess up in that one, which is pretty cool. Part D, probably a lot of opportunities to mess up. You have two variables. They almost look the same. You have a fraction and a cubic and a lot of negatives. So you have 2 times, oh, let's see, part D. 2 times -2 over 3 minus 1. Again, good habit to wrap around parentheses, especially right here. Minus -2 quantity cubed minus 3. All right, here we go. 2 times -2 is -4. 3 minus 1 is 2. You have -4 over 2. Minus -2 cubed is -8. Minus 3. -4 over 2 is -2. Minus -8 is adding 8. So that'll become plus 8 minus 3. -2 plus 8 is 6. 6 minus 3 is 3. There you are. And the final problem If part C where f of k equals negative 4 over k plus 7, what value of k would be excluded from the domain? Remember when we talked about domain restrictions right here? So now we're referring to a graph. It says, are there any x values, in this case, are there any k values for this next one that I can plug in that would not give me a y value in f of k, right? F of k is y. Are there any restrictions? The answer is yes, there is a restriction. This, here, let me write it over here. This k value is in the denominator, meaning there is a chance that the denominator can become 0. If I plug in some value for k, my denominator becomes 0. I'm dividing by 0, and I can't do that. You literally can't. Negative 4 divided by 0 is not 0. It does not give you a number. So the idea here is I have to say that k plus 7 cannot equal 0. So treat this like a solve for k kind of equation. Subtract 7 from both sides. And what value can k not become? K cannot equal negative 7. If k was negative 7, if we substituted negative 7 in for k in this equation, if we took f of negative 7, we would be getting negative 4 over 0, which is undefined. So that is a restriction on my domain. So you would probably write it like this, domain, k cannot equal negative 7. What that means is k can equal anything else. But if it equals negative 7, it goes kaput. All right, that's the restriction on the domain for that. And all right, so that's it. Hope that was helpful for you. Study that up, and you'll be good to go. Fiend!